Good morning, everyone. Is my voice clear and audible? Is my voice clear? Good morning, Sujan. Okay, so okay, so my voice is clear. So we will start today. We will start wave optics. Previous class we have covered unit and dimensions. Now we are going to start with wave optics. There are a lot of things to be studied in this chapter. We will start first of all. We will start wave nature of light. That is wavefront. What is Huygens principle? Then we will study about interference, YDSE, diffraction, and polarization. Now listen to me very carefully. Before that, we have covered dual nature, or you can say photoelectric effect we have covered. Good morning, Luby Duby. Lobby Duby. Okay. Uh, we have covered dual nature or photoelectric effect. In that, we have seen that light behaves as a particle, or those particles were named as photons and called as bits of energy. They have certain energy. Now, there are certain phenomena as well which can be explained using wave nature of light. The few phenomena out of those are mentioned here, that is interference, diffraction, and polarization. These are the three phenomena which can be explained using wave nature of light. So in this chapter, we will study the wave nature of light. Okay, starting. First thing that comes our mind is what is wavefront. So let me explain you. The definition is mentioned on the screen, but just look at me. Whenever you throw a stone in water, in pond, in somewhere in sea, or whatever it is, whenever you throw a stone, you see some waves are generated. And in short, if I say the face of the wave, how it looks is called wavefront. The face of the wave is called wavefront. But the definition according to physics becomes the locus of particles vibrating in same phase. Now look at that. Let's suppose this is, uh, are you getting this point? The locus, for example, this is a point, this is a source of anything from where waves are generated. So waves will be generating like this in all the directions, like this. When waves are generating like this, then the particles, these are the particles which are vibrating up and down, up and down. So the points where the particles are in same phase, these are the particles when they are in highest position. So the locus of these points is called wavefront. Locus of those points which are in same phase, either they are simultaneously at the maximum position or simultaneously at the lowest position, is called a wavefront. So wavefront, in short, is the face of the wave, how it looks, or in definition of physics, it is the, what is it? Locus of points, particles vibrating in same phase. Now there are two or three critical punchlines that I will explain you. Wavefront travels with the speed of light. Very important point. The speed of light is denoted by c. A line perpendicular to the wavefront gives the direction of ray propagation. I will explain this point again. So first of all, there are certain situations, for example, how wavefront looks, that is for point source of light. If there is a point source, then how wavefront will look? Suppose this is a point source. So the wavefront for this point source will be something spherical shell, concentric spherical shells. This is what? Spherical shells. These are the wavefronts for the point source of light. Clear? Now, one more punchline I will add here. That punchline is, if point source is very far. Very far, what does it mean, very far? That means it is at infinite distance, like sun is at infinite distance from us. Sun is at infinite distance from us, so it is very far. Very far means infinite distance. Clear? In that situation, you can see that if this source is very far from us, then this spherical shell will be of very large radius. If this spherical shell will be of very large radius, so we can say that in that situation, wavefront will be plane. Plane means flat wavefront. So the wavefront will look something like that. These are the wavefronts, which are flat. These are the wavefronts for a point source placed at infinite distance. So this is the punchline that you should remember. For a point source, wavefronts are spherical in nature, but if point source is at infinite distance, then it is flat wavefront. Now, one more thing that I was explaining you. A line perpendicular to the wavefront gives the direction of ray propagation. Like, this is the point source. If I draw a line perpendicular to these spherical shells like this, so this will give the direction of ray. In ray optics, we have taken rays. If there is a point source, there is a source of light from which at least take two rays. So these are the rays. These rays are perpendicular to the wavefront. Like these are the wavefronts. So ray will be perpendicular to them. Something like that. So these are the rays. Is this point also clear? Okay. Wavefront thing is clear. Now moving further, there is a Huygens principle. Huygens was the first person to say that light has a wave nature. What he says, every point on a wavefront behaves as a point source of light. Every point on a wavefront behaves as a point source of light. This is just the statement. And why? What is the significance of this statement? Using this statement, Huygens explained how light travels. What he explained? How light travels. And he can determine, or anyone can determine, the position of next wavefront. So I will explain it again. Light travels, according to wave theory, light travels in the form of wavefronts, in the form of waves, which has some wavefront. And if you know the position of one wavefront, then you can determine the position of next wavefront using Huygens principle. So this point is not to be explained here because it is not going to come in your NEET examination, that how we can determine the position of next wavefront. But we can do a simple question on that. That's on your screen. This is a very important question. The question says this is a convex lens and plane wavefront is incident on it. Draw the refracted wavefront. The question says draw the refracted wavefront. So the method of doing it is very simple. What I will do, the standard procedure is draw the rays, because what you see, you know that you can draw the ray diagram for the convex lens. That is for sure. So we don't know about wavefront things, so we can deal it with rays. So I will do, just draw the rays of these wavefront. This ray is just, if I try to draw the rays, the line perpendicular to them will be the ray. So I have drawn the line perpendicular to them. Again, there is one more ray I have drawn. Now tell me if these are the rays. These are the paraaxial rays parallel to the principal axis. So they will meet at the focus. They will meet at the focus. Is this point clear till now? They will meet at the focus. Now our next task is to draw the wavefront. Wavefront, we know that wavefront is perpendicular to the rays. That is the thing that we know. Wavefront is perpendicular to the rays. So take the center as this focus point or this meeting point where the two rays meet and draw circular arcs. Taking this point as a center, draw circular arcs. And if you draw circular arcs, they will be something like that. So these are the refracted wavefronts. These are the refracted wavefronts. Is this point clear? Is this type of question you can solve? Now, what is your task? You have to draw this same situation for concave lens as well and identify what will be the refracted wavefront. Okay, that is your task. This is an important thing. You should remember this. The procedure you should remember for draw the ray diagram and then draw the perpendicular on the rays. This way you can solve. Now comes interference of light. This is the most important topic from where most of the questions are asked. Interference means, what is the meaning of interference? When two or more persons interfere in each other tasks, that is generally called interference. Don't interfere in my task, in my work, don't interfere. This is the common phrase. Okay. So what is the interference of light? Interference of light means when two or more light waves which are traveling in the same medium interfere. Or you can say the superposition of light waves traveling in a medium is called interference. When two or light waves interfere with each other, that means superposition of light waves is called interference of light. This is a simple definition. Now, what can happen in interference? Listen. There are two types of interference that can happen. One is constructive, one is destructive. One is constructive, one is destructive. Let's suppose. Just look at that. Let's suppose this is a wave. Clear? Let's suppose this is wave number one. And this is wave number two. You can see that both these waves are in same phase. Both these waves are in same phase. Where it also starts from the same point. When it is at highest point, it is also at highest point. When it is at lowest point, it is also at lowest point. That means they are in same phase. When the waves are in same phase, then the interference between them is known as constructive interference. That means when these two waves meet with each other, or there is a superposition of these two waves, the amplitude of the resultant wave will increase. This is known as amplitude. I think you know that the amplitude of the resultant wave will increase. So what is constructive interference? When the waves meet in same phase, the resultant displacement increases, or you can say resultant amplitude will also increase. Is this point clear? When the two waves meet in same phase, then it is known as constructive interference. And what is the purpose of this constructive interference? The displacement, or you can say amplitude of the waves increases. Next is destructive interference. What is destructive interference? When the waves in opposite phase meet, like this. This is the third wave. And you can say wave 1 and wave 3 are in opposite phase. When it is highest, it is lowest. When it is lowest, it is highest. That means they are in opposite phase. And the phase difference between first and 3 is 180 degree. Phase difference between 1 and 3 is 180 degree. Is this point clear? So destructive interference happens when they meet in opposite phase, and in this situation displacement decreases. So we are now aware of the constructive and destructive interference. When it is going to be a constructive, when it is going to be a destructive interference, you should know. Now, one more thing that I will explain here. Same phase, two waves. I think you know that this is point 0, this is pi, this is 2 pi, 3 pi. Similarly, there will be a 4 pi. So two waves are in same phase whenever there is a phase difference of 0 degree, 2 pi, 4 pi, 6 pi, or so on. Whenever the phase difference is of any one of these, the waves are in same phase. Similarly, when they are in opposite phase, whenever the phase difference between them is either pi, 3 pi, 5 pi, 7 pi, and so on. I think you can understand that this is the odd integral of pi. This is the even multiple of pi. Odd multiple of pi, even multiple of pi with 0. That's it. Now interference of light. One more thing about interference of light. Listen each and every word. I think you know this from your class 12th. But the thing is, let's suppose two light waves are coming. One is from S1, another is from S2. These two light waves are coming. And when they meet, the equation of them is A1 sin omega t and A2 sin omega t plus phi. What is phi? Phi is the phase difference. Phi is the phase difference between the two waves reaching at point P. Then when these waves superimpose with each other, when these waves superimpose or meet at any one point, the intensity of the light, at that point is proportional to the amplitude square, where amplitude A is the amplitude of the resultant wave. So I will mention here A is the amplitude of resultant wave. And intensity is directly proportional to A square. This is the thing that you should remember. Always intensity is proportional to A square. Next, if I solve this, intensity is found to be A1 square, A2 square plus 2A1, A2 cos phi. Now, this is standard relation is to be understood very carefully. A1 is the amplitude of the wave coming from S1. A2 is the amplitude of wave coming from S2. Is this point clear? So intensity is A1 square plus A2 square plus 2A1, A2 cos phi. Now this can also be written in another way. This is the another way. Intensity at the point P is I1 plus I2 plus 2I1, I2 cos phi, where I1 is the intensity from S1. I think you remember S1. This is the S1. And I2 is the intensity from S2. From S2. Phi is what? Phi is the phase difference. If you don't know this formula, then write this formula. This is the most important relation. Very important relation. You can remember this formula. Clear? Now again, there are certain conditions for maxima that I have told you. For maxima, the phase difference should be what? They are in same phase, and same phase means 0, 2 pi, 4 pi, dot, dot, dot. So how it can be written as? It can be written as 2n pi. It can be written as 2n pi, where n is what? 0, 1, 2, 3, so on. I think this is the relation you should remember. The thing you can remember is same phase. What you can remember? Same phase. And when two waves are same phase? When there is the phase difference is 0, 2 pi, 4 pi, dot, dot, dot. Now, one more thing. The same condition of maxima will be when path difference is n lambda, where lambda is the wavelength. Lambda is the wavelength. N is again 0, 1, 2, 3, whatever you can say. 0, 1, 2, 3, dot, dot, dot. Delta x is the n lambda. That means, listen again. Let's understand these things. For example, there are two waves meeting at P. One is coming from S1, one is coming from S2. If the path difference, you can see that the path covered by S1 wave is S1P and by S2 wave is S2P. This is the path. This is suppose L1, this is suppose L2. So the path difference between them, delta x. If this delta x is either lambda, 2 lambda, 3 lambda, only then they will produce constructive interference. They will produce constructive interference. So what I am talking about the path difference of the two waves. If this path difference is integral multiple of wavelength, then they will produce same phase of light or produce maxima or constructive interference. Now, what are the conditions for minima? Minima means destructive interference. For destructive interference, we know that phase difference should be there. They should be in opposite phase. Opposite phase means pi, 3 pi, 5 pi. So how this can be written in terms of n? It can be written as 2n minus 1 pi. If you place n equals to 1 here, then it will become pi. If you place n equals to 2 here, it will become 2 to 4 minus 1, 3 pi. If you place n equals to 3, it will become 5 pi. You can check that. After that, the same relation in terms of path difference, that means the path difference between them should be 2n minus 1 lambda by 2. If you place n equals to 1, it will become, tell me, if you place n equals to 1, it will become lambda by 2. If you place n equals to 2, 3 lambda by 2, 5 lambda by 2. Can you see that it is odd multiple of lambda by 2? Odd multiple of lambda by 2. Very good. Odd multiple of lambda by 2. Can you see this? Or that was the, in this case, it was 0, lambda, 2 lambda, 3 lambda, 4 lambda, something like this. Is this point clear? Moving further. Now, one more relation that you should remember, I will tell you here. Relation between phase difference and path difference. Phi is equals to 2 pi by lambda delta x. Remember this formula. Phi is equals to 2 pi by lambda delta x. The origin of this formula is also very simple, but this origin should not be explained here, I think, because it's just a crash course. So what I'm saying, phi is the phase difference is equals to 2 pi by lambda delta x. For example, if someone told you that that path difference is lambda by 3, what if someone says that path difference is delta x? The question says, if delta x is equals to pi by 3, sorry, lambda by 3, what is the path difference? Lambda by 3. So phi will be 2 pi by lambda into delta x. Delta x is what? Lambda by 3. It will be cancelled. That is 2 pi by 3. That means the use of this equation, this relation is, if you know the path difference, you can calculate the phase difference. And why phase difference is required? Because we know that intensity is dependent on the phase difference. So question paper will contain path difference only. And they will ask you the intensity. Are you getting my point? They will give you the path difference and ask you the intensity. For intensity, you should calculate phi. And phi will be calculated using this relation. I will give you some example on that. So don't worry about that. But the thing should be clear here only. Moving further. Now, ratio of maximum and minimum intensity. Intensity formula you have learned here. I is equals to I1 plus I2 plus 2 root I1 I2 cos phi. That's what we have learned here. Till now, this is the equation. Now, for maxima, I am repeating the things. That's why I have left this slide blank. I am repeating the things. For maxima, what you know that phi is equals to either 0 or 2 pi or 4 pi. Whatever it is, if phi is 0 or 2 pi, whatever it is, cos phi is going to be 1. So I max is going to be I1 plus I2 plus 2 root I1 I2, and cos phi is going to be 1. Why 1? Because I think you know that na, cos 0 is 1. Cos 0 is 1. So this is I max. Now if I write about I minima, for minimum we know that phi should be what? Either pi or 3 pi or so on. So if phi is pi, cos pi, yani cos 180. Cos 180 is what? Minus 1. Cos 180 is what? Minus 1. You know that, no? So what it will become? I minima is equals to I1 plus I2 and 2 I1 I2, and cos phi is minus 1. So minus is placed here. Can you see that it will become root of I1 plus I2 whole square? Can you see this? If you whole square it, it will become this same term. Similarly, it can be written as root of I1 minus root of I2 whole square. So if you want to calculate the ratio, so this ratio will become I max over I minimum is equals to root of I1 plus root of I2 divided by root of I1 minus root of I2 whole square. Is this point also clear? Is this point clear to you? I max over I minimum The ratio is something like that, and this is the golden formula. This is the golden formula. Golden formula means you should always remember this relation. Now, one more form in which I can break it out. One more format in which I can break it out. That will be the above the golden box. Above the golden box means more important than this one as well. So I am just doing nothing. I am just breaking it in another form. And if you can understand, I am skipping few steps. So listen to me very carefully. What if in the numerator, if you take I2 common, if you take I2 common, then what it will be? If you take I2 common, it will become root of I1 upon I2 plus 1. Is it clear? And if you take I2 common from this as well, it will become root I1 over I2 minus 1. So I max over I minimum will be the root I2 that you have taken common will be cancelled by the root I2 that you have taken common from denominator as well. So both the I2s will be cancelled. So it will ultimately become root of I1 over I2 plus 1 over root of I1 over I2 minus 1 whole square. This is personally my favorite form of ratio. I think this spelling was wrong. Max AX. This is personally my favorite form, and you should remember this in this way. Root I1 over I2 plus 1 over root I1 over I2 minus 1. Why it is very important, I will tell you in a question. But till then, keep it in mind. Till then, keep it in mind. Clear this point? Moving further. Now there comes very famous young double slit experiment, YDSE. YDSE. I have mentioned the formulas here. Before that, I will explain you the setup. The setup contains, there is a screen. There are two slits S1 and S2. These are two slits S1 and S2. Now there is a source S, and there is one single slit S0. What will happen? The light coming out from S1 and S2 will interfere. And if you see that the light reaching the point, if I say this is the midpoint of S1 and S2, then light reaching at this point, tell me which distance is more. If C is the, or you can say this is the midpoint of S1 and S2, and this is just opposite to that point, then S1C or S2C, which one is more, or they are equal? They are equal, or which one is greater? S1C is greater. Okay. This is the midpoint. Equal. Very good, Chichuni. Equal. S1C and S2C both will be equal. Why equal? Because this point is the midpoint, and opposite if I go, then the distance will be same. If distance is same, that means the path difference is going to be zero. Path difference is going to be zero. And this point where path difference is zero, we will get a maxima. What is the condition for maximum? The path difference should be either zero, either lambda, 2 lambda, 3 lambda, 4 lambda, and so on. So at this point C, the path difference is lambda. If the path difference is lambda, that means this is the maxima, and this point is at the center of the two slits. So this is known as central maxima. What it is called? Central maxima. Very important thing. Central maxima we know now. Now, if I move away in the upward direction, then you can see, let's see, we have moved at a distance y from this point C. Now you can clearly see that S1P is smaller than S2C, S2P, because S2P wave has covered longer distance. Can you see this? If this distance is more, that means there is a path difference. So what will be the value of this path difference if I use some geometry and trigonometry simultaneously? Then I will get this path difference as y d by d. Remember this word y small d by capital D. What is small d? The separation between the two slits. Capital D is separation of these screens. The path difference, you should remember y small d over capital D. This is the path difference. I think you understand what is the path difference. In the diagram, what is the path difference? This portion is the path difference. This is the extra portion that I have highlighted. This is the path difference, which is denoted by delta x. Moving further. Now, what is the position of maxima? What will be the position of maxima? Position of maxima will be n lambda capital D by small d. Now, remember one thing, this time capital D is in the numerator. In the previous slide, small d was in the numerator. So don't get confused. Y is equals to n lambda capital D over small d, where n is what? 0, 1, 2, 3, and so on. Write down the formulas. Write down the formulas, otherwise it will be confusing for you. Very good, Balveer. Good morning. Position of minima. Position of minima is n minus 1 by 2 lambda capital D by small d. You can notice here lambda capital D by small d is common. The term here was n only, and the term here is n minus 1 by 2. Nothing difference. This is n minus 1 by 2 lambda d by d. Clear? Now one more thing I will explain here. If you put n equals to 0, it will be known as central maxima. If you put n equals to 1, it is first maxima. And what will be the position of first maxima? Y1 is equals to lambda d by d. If you put n equals to 2, it will become second maxima. And y2 will be, if you put n equals to 2, it will be 2 lambda capital D by small d. So can you calculate fifth maxima, seventh maxima, whatever maxima they can ask, you should calculate, or you should know how to calculate it. Now, if I place n equals to 1 here, it is known as first minima. And what is the value of that minima? Y1 is equals to, can you tell me, n minus 1 by 2, that is 1 minus 1 by 2. That is 1 by 2 lambda d by d. If you place n equals to 2 here, it will become second minima. And y2 will be 3 by 2 lambda d by d. Similarly, 5 by 2 lambda d by d, 7 by 2 lambda d by d, and you will get lot of minimas from this. So till now, what we have understood, what is condition of maxima, what is the position of maxima, what is the position of minima. Now intensity curve. This is the position. This is the intensity. And this is the central maxima, that is O, I will say, or whatever C it is mentioned. Now the intensity is maximum. Intensity decreases, and at this point becomes 0. Intensity becomes 0, and this point is first minima. This point is first minima. First minima is lambda d by d into 1 by 2. This is second minima, lambda d by d And what is it? 3 by 2. Is this clear? Similarly, this is on the negative side. So you can say minus lambda d by d 1 by 2. You can place these values similarly in this point, at this point, and at this point as well. Now, can you see that this is central maxima and this is the first maxima? This is the maximum intensity. If this is the maximum intensity, then its value first maxima. What is the value of this first maxima? Lambda d by d. This is second maxima. Lambda d 2 lambda d by d. These are the maximas and these points are the minima. Similarly, you can write it on the left side as well with a minus sign. Now, point to be noted here. The intensity of all the maximas, whether it's second maxima, it's first maxima, central maxima, or whatever it is, all the intensities are same. That means punchline is intensity of all maxima are same. Intensity of all maxima are same. Do you know what is actually, if I say at this point of time, at this point of time, is the minima correct? Which minima? Here or here? Graph. Okay. What's wrong with it? Have I placed anything wrong in it? This is the minima, first minima. Lambda d by t 1 by 2. 3 by 2 lambda d by d. Similarly, 5 by 2 lambda d by t. Where else do you stream, sir? Where else do I stream the meaning of this statement? Okay, Balveer, it's on Zoom. Okay, Chichuni, what were you asking? Okay, now moving further. Intensity of all maximas are same. This is the punchline that you should remember. 2 lambda d by d. 2 lambda d by d. 2 lambda d by t is the maxima. 2 lambda d by d is the maxima. This is the maxima. And minima you can see here. Na? First minima is what? 1 by 2 lambda d by d. 3 by 2 lambda d by d. These are the minima. Minima. What is the maxima? Lambda d by d, 2 lambda d by d. These are the maximas. N times lambda d by d. And that is n minus 1 by 2 times lambda d by d. Okay. Moving further. One more thing that I can explain you here. I was explaining something else actually. Fringe width. Fringe width was the distance between two successive bright or dark fringes is called fringe width. Can you see that? One dark fringe is this one. This is first dark fringe. This is second dark fringe. The separation between these two is called as fringe width. Similarly, this is the first maxima or first bright fringe. This is the second bright fringe. This separation between them is known as fringe width. And this separation is calculated as lambda d by d. So this is again the most important relation. This is again the most important relation. Is this point clear as well? Beta is equals to lambda d by d. One more point now. This beta is directly proportional to lambda. You should remember. You can see this as well, but I want you to pay attention on this. Beta is directly proportional to lambda. Now, what if I say that wavelength of light used is increased? Then fringe width will also increase. Sir, you wrote a minima and maxima as common minima on intensity curve page. I think you are asking this term, na, as common minima. Okay, that's what you are saying. This is the thing. Okay, this is the thing I have told you that these points are minimas. Similarly, this point, the point where intensity is minimum is called minima. So I am not saying this is the same minima. This is the first minima. This is second minima. But the thing is, okay, okay. That's what the thing is that you were asking. This is minima. Clear? Right now it's clear now. The point that I have mentioned, the arrow was wrong actually. So this is minima. Clear now? This is maxima. Very good, Balveer. Okay. Okay. So fringe width is proportional to lambda. That's what we have achieved. Now, punchlines. First punchline says for red color fringe, width is more compared to violet color. This is what? We know that there are 7 colors like Vibigure. Out of these spectrum, red color has highest wavelength. Red has highest wavelength and violet has lowest wavelength. I think this point you know that. Now, if I say, if I move from red to violet, the wavelength decreases. Red to violet, if I move, wavelength decreases. For in that scenario, what is it is? Beta is proportional to lambda. We have seen on the previous slide. Beta is proportional to lambda. That means for red color, wavelength is more, so beta is also more. This is the first punchline. Second punchline is also very important. If the whole YDSE setup is immersed in a liquid of some refractive index mu, then fringe width will decrease. And how much fringe width? Then it will become new fringe width. Beta dash is equals to 1 by mu times beta. Again, a punchline, mark it in a box. Beta dash is equals to beta by mu, where mu is the refractive index of the liquid in which it is immersed. Next punchline, only coherent source can produce interference. Now tell me, what are the meaning of coherent sources? Can anyone tell me? Can anyone tell me what is the meaning of coherent sources? Anyone knows? Uh, Veena, Ayushi, Sushant. Constant path and phase difference. Okay. Remove path from it. Remove path from it. Just only constant phase difference. Two sources are coherent or said to be coherent if the phase difference between them or the initial phase difference between them is constant. The mark my word, if initial phase difference between them is constant. Coherent sources are those in which initial phase difference is constant. The waves emerging are constant phase, are in same phase or constant phase. And the frequency is same. Only then the sources are said to be coherent sources. So the thing is, Only coherent source can produce interference. If the sources are not coherent, they cannot produce interference pattern. I will mention one more word, interference pattern. It's not like they will not interfere. They will interfere, but they cannot produce the pattern. The pattern was bright, dark, bright, dark, bright, dark, bright, dark. This is the pattern of interference. Now it's time to do some questions. First question is very simple. In Young's double slit experiment, if the separation between coherent sources is halved and the distance of the screen from the coherent source is doubled, then the fringe width becomes. So first of all, they are talking about fringe width. Fringe width is what? Beta is equals to lambda capital D by small d. This is the formula. During the whole process, lambda becomes constant. Lambda remains constant. They are not touching the lambda. They are just dealing with capital D and small d. So you can write as beta 1 over beta 2 is equals to d1 over d2 into small d2 over d1. Because small d is reciprocal. Now one more thing. What is mentioned in the question? Question says, if the separation between coherent sources, the separation between coherent sources like this, these are the two coherent sources S1 and S2, which is denoted by D. This separation is halved. Let's suppose D1 and D2. If D1 is 2D, it will become D, half ho gayi. Now capital D, if I talk about, there is capital D1 and capital D2. And the distance of the screen from the coherent source is doubled. That means if it is D, it becomes 2D. Now place the values. If I place the value, D1 over D2 is D over 2D into D over 2D. You can cancel. So beta 1 over beta 2 will become 1 by 4, or beta 2 will become 4 times beta 1. That means fringe width will become 4 times. Simplest of the questions. You have to do nothing in that. Very simple. Moving further. Tell me the answer of this. I am not going to solve it out. This is the formula based question. In Young double slit experiment, if there is no initial phase difference between the light from the two slits, a point on the screen corresponding to fifth minimum has path difference. You can find it using the formula. It will be C, 9 lambda by 2. I will not take a lot of time in it. Now, this is the good question. This is very good question. Remember, the question says in the YDSE experiment, the intensity of light at a point on the screen where the path difference is lambda is K. Okay. What is mentioned? The point at which path difference is lambda, intensity is K. First of all, you should write the formula for intensity. I is equals to I1 plus I2 plus 2 root I1 I2 cos phi. This is the formula for intensity. So when I talk about YDSE, now listen one more time. If it is visible, this is YDSE setup. This is S1, this is S2. So in YDSE setup, original YDSE setup, the intensity of light coming out of this S1 and S2, the intensity of these two are equal in original YDSE setup if nothing is mentioned. Like sometimes the question says that S1 is covered partially. That is the different case. Or the slit width of S1 is less than the S2. That is another thing. But in ideal situation, whenever nothing is mentioned, these two intensities are always same. These two intensities are always same. Clear this word? Now, question says, mark my word. The question says the intensity is K. So I have placed here as K. Both the intensities I1 and I2 are same. So I have placed them as I plus 2I. Path difference is lambda. So if path difference is lambda, I can delete this thing. So whenever the path difference is lambda, what will be the phase difference? So we know that phi is equals to 2 pi by lambda delta x. This is the relation I have explained you. According to the question, delta x is given as lambda. So it is 2 pi by lambda into lambda. Phi becomes 2 pi. And cos 2 pi is what? Cos 2 pi is 1. So it will become k is equals to I 2I, that is 4I. Let it be equation number 1. In the next situation, they are saying the intensity at a point where the path difference is lambda by 4. Now they are saying that lambda by 4 is the path difference. So whenever the path difference is lambda by 4, the phase difference will be phi is equals to 2 pi by lambda into lambda by 4. Lambda, so phi is equals to pi by 2. Phi is equals to pi by 2. Now use this relation again. I have placed the equation. So new once again, new intensity, let's suppose it is I dash. Both the intensities I1 and I2 are same. So it will become I plus this term is 0. Why 0? If I place phi as pi by 2, cos 90 is 0. So I have termed this as 0. So new intensity is 2I. From equation 2, this is the equation 2, you can see that 4I is equals to K. So 2I will be K by 2. K by, this is our answer. This is our answer, which is option number C. Very good, Balveer. Very good, Chichuni. Moving further. This is again an important question. Question reads, read it again. In YDSE experiment, what is it? It is small d or capital D? Can you identify? There are two wavelengths. Lambda 1 is 12,000 angstrom and lambda 2 is 10,000 angstrom. Clear. Now read the question. At what minimum distance from the common central bright fringe on the screen, which is 2 meters from the slit, will a bright fringe from one interference pattern coincide with a bright fringe from the other? Okay, so language might be very much difficult for you. They are saying that in a YDSE experiment, they are using two lights. They are using two lights. And this is the common central maxima C. So they are saying the least distance from this common central maxima where the uh, maximas will coincide for the first time. Where the maximas will coincide for the first time. So listen. The position of maxima, if I say, position of maxima is n lambda d by d. This is the position of maxima. You can see that if lambda is more, position will also be on the higher side. If lambda is more, position will also on the higher side or will be more. So that means one thing that you can assume, if nth maxima of lambda 1 is at point P, then n plus 1th maxima of lambda 2 will be at the same point, where n is the number which I have assumed that nth maxima of lambda 1 will coincide with the n plus 1th maxima of lambda 2. Why there is only difference of one maxima? Because they are asking the least difference. So in this situation, what you can do, nth maxima will coincide with the n plus 1th maxima. So these two distances should be equal. And if these two distances should be equal, then nth maxima is n lambda 1 d by d is equals to n plus 1 lambda 2 d by d. Now you can cancel out the things. D by d will be cancelled. Lambda 1 is 12,000. So n into 12,000 is equals to n plus 1 into 10,000. I have mentioned correctly. Now you can again simplify these things. 1, 2, 3, 1, 2, 3, 6 and 5. So 6n is equals to 5n plus 5. What is the value of n? So n is equals to 5. If I am not wrong. N is equals to 5. Clear? Now put n equals to 5 in this value. You will get the answer. What is the meaning of this n equals to 5? That means fifth maxima of lambda 1 coincides with the sixth maxima of lambda 2. So we need to find this distance. So distance y is equals to n is 5, lambda is 12,000, 12,000 into 10 raised to power minus 10 angstrom. D is given as 2 meter divided by small d is given as 2 mm. That is 2 into 10 raised to power minus 3. You can simplify it. It will become 336 minus 4 and 10 from 60. That is 6 into 10 raised to the power minus 3. That is 6 mm, which is option number D. Which is option number D. This is the question you should answer in 1 second time. Within a second, you should answer. Do it quickly. Yellow light is replaced by blue light. You know that Vibgyor. Yellow light is replaced by blue light. Option number B. Veena is saying option number B. Okay. Yellow is replaced by blue light. That means new light is blue. So lambda is decreasing. Can't you see that? Lambda is decreasing. Then lambda is decreasing. B is proportional to lambda. If lambda is decreasing, beta should also decrease, Veena. So fringe width will decrease, not increase. I think you have read the question in a wrong way. Will decrease. Very good, Balveer. Now one more punchline that I will explain you. We have one more time, one more minute, I think. The question says, the question is not mentioned here. What I'm saying, in YDSC, let's suppose two light sources are, there are two sources S1 and S2, two current sources S1 and S2. So the ratio of light coming out of them, I1 over I2 is 9:1. This is a very simple question. The intensity ratio of intensities coming off S1 and S2 is 9:1. Find the ratio of maxima and minima. Find the ratio of I max over I minimum. Do you know the relation? I told you. What was that? I max over I minimum is equals to root of I1 over I2 plus 1 over root of I1 over I2 minus 1 whole square. Can you place this value? Can you place this value and get the answer? I1 and I2 is given. One more punchline. In YDSE, this is source 1 as 2. Two slits are there. One more thing that is mentioned sometime, width of this is given as W1 and width of this is given as W2. They say that the width of the two slits are not similar. They are not identical. If the width is not identical, in that situation, intensity of light coming out of them will not be equal. We have assumed that it is I and I same. Okay, Balvir has calculated it as 4. I don't know. I think someone has mentioned it as 4. Anyone else can check it out and get the answer. So, okay, 4/1, very good. Veena is also saying 4/1, so I am mentioning it 4:1. Very good. Okay. So what I am saying, intensity is directly in this, intensity is directly proportional to the width. So intensity I1 over I2 will be W1 over W2. W1 over W2. This is the another thing that you can see or notice. If the slit widths are same, then intensity will be same. If the slit widths are not same, then intensity will be in the ratio of slit widths. Clear? Now there are much more variations. If these monochromatic lights are replaced with white light, so I think time is pretty much more. 9 minutes are already over. So I am ending the session. In the next session, next class, we will discuss about some diffraction things. Till then, bye everyone. Bye everyone.